Sliding ladder. A 30 feet ladder is leaning against a wall. The bottom of the ladder is sliding away from the wall at 3 feet per second. How fast, which is rate of change, is the top of the ladder sliding down when the bottom of the ladder is 10 feet away from the wall? Alright, so to do a related rate problem, first of all, you need a graph. So I have a bad news for you. Most of the time, when you see a problem on the test, quizzes, and homework, you don't get a graph. So your responsibility is to read the problem and sketch the graph by yourself. So I already have a graph ready for you. Let's take a look. We have a wall, and then this is the ladder. So we have the top of the ladder, the bottom of the ladder, and then the ground. So a ladder is leaning against a wall, and then the bottom is sliding away. So the bottom is going to the right hand side. And then we have some givens. So let's label the graph first. Okay, so the ladder is 30 feet. We don't need a variable for that because the length of the ladder is not changing. And then the top of the ladder to the ground, let's call this a y. And then from the bottom on the ground, let's call this x. So what else do we know? The ladder is 30 feet, and then the bottom is sliding away. So we have a dx dt with respect to time that is equals to 3 feet per second, right? All right, so that is 3 feet per second. So 3 feet per second. Is dx dt supposed to be positive or negative? The answer is positive because the distance, so did you see this? Do you see this distance? So as the bottom sliding away, the distance is increasing. So that's why dx dt is positive. What about dy dt? Do we know? What is the rate of change of the top of the ladder sliding down? So it looks like dy dt is unknown. So dy dt is unknown. They are asking for this. When the bottom of the ladder is 10 feet away from the wall, so when x is equals to 10 feet away from the wall. Alright, so that is the graph and labels, and then the next step is equations. So let's draw the equation. So since this is a right triangle, I will be using the Pythagorean theorem, which is the square of the base plus the square of the height equals to the square of the hypotenuse, which is 30 square. Alright, and then we use implicit differentiation, divide both sides, take the derivative on both sides with respect to time. So power rule 2x, and then we have a dx dt, and then plus 2y, and then dy dt, and then the derivative of 30 is equals to 0. And then plug in everything you know. So we have 2, x is equals to 10, dx dt is positive 3, and then 2, dy dt we don't know, and then y, we don't know y as well. So dy dt, and then that is equals to 0. So we have to figure out y first before we calculate dy dt. So for the y value, which is the bottom to the ground, we have to use another triangle. So let's draw another triangle. So this is y, and then x on the bottom is equals to 10, and then the length of the ladder is 30 feet. So we use another Pythagorean theorem, 10 square plus y square equals to 30 square. So we have y square equals to 900 minus 100, right? So y square is equals to 800, and then y is equals to the square root of 800. That is approximately equals to 28.28 feet. All right, so y is equals to 28. So this is your y, and then now we can solve for dy dt. Okay, so back to that color. So you have a 6 times 10, that is equals to 60, right? So we have 60 plus 2 times 28, 28.28, huh? I wrote a 28. So that is supposed to be 28.28. Okay, I'm going to be lazy, just type 2 times 28.28. And then dy dt, that is equals to 0. And then the dy dt is equals to, first we subtract 60 on both sides, and then we divide by 2 times 28.28. So this one, I have this approximately equals to negative 1.06. Negative 1.06, the unit is in feet per second. What does that mean? How come the rate of change is negative? So y stands for the distance between the top of the ladder to the ground, right? So right here, look at my pointer, the top of the ladder and the ground. So it is negative 1.6 feet per second. That means the distance between the top and the ground is decreasing. So the ladder is sliding down, right? So this part is going away. This part is going to the right, and then this part is moving down. So that means the distance between the top and the ground is decreasing. That's why the rate of change is negative. All right, so let's add a description. So this is negative rate of change. I use ROC because the length of y is decreasing. So the length of y is decreasing. And then the top of the ladder is approaching to the ground. So the top of the ladder is approaching to the ground. Alright, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me. If you are new to the channel, click the subscribe button. I will catch you all in the next lesson. Signing out.